Overcoming gravity by using air. Overcoming gravity by floating in air.
There goes another one.
Hot air is lighter than regular air, so by heating up the air inside a balloon, hot air balloons can rise up in the sky and you can overcome gravity in this
They're
way.
moving pretty fast.
There are gases like helium and hydrogen that are lighter than regular air, and you can use these gases inside a balloon to make vehicles that are lighter than air, and you can overcome gravity with these. These are blimps, like the Goodyear blimp, which uses helium. Pushing against air for propulsion. In addition to using air to help lift vehicles in the air, you can also push against air to get propulsion. All sorts of vehicles can do this. Here is a boat that uses a big fan to push against the air. Airplanes use air to push up on their wings to get lift, but they also move a lot of air. Here's a clip of the Blue Angel's FA-18 Hornet, and watch how much air it moves underneath the plane. It doesn't have to look like a helicopter to use the same principles. A Harrier jet does the same thing essentially. It pushes a lot of air straight down in order to be able to rise straight up off the ground. Because it's such a large craft, though, it uses a lot of power to do this. Here is a way of visualizing how an airfoil works using a wind tunnel and pulses of smoke. You can see in these how the air is moving faster over the top of the airfoil. Controlling an airplane: rudder, elevator, and aileron. The same principles apply to larger airplanes and jets. It just takes a lot more power. Being able to go straight up like this is almost like a rocket instead of a jet, except it still needs air to work, which is the difference between a rocket and a jet like this. A rocket doesn't need air.
Jacob, towards us. Ready when you are.
Another small rocket launch. You can also launch two-stage rockets. The engine
Oh! Coming at you, Jacob.
For the launch of a larger rocket, we used a small movie camera and taped it to the rocket. Here's what the flight looked like from the ground. And here's what it looks like from the rocket's point of view.
Yeah.
Okay, here we go.
No, I see it.
Okay. 3, 2, 1.
From the small rockets, let's talk about the largest rocket, the Saturn V. This is the most powerful machine ever built. The first stage is powered by 5 of these engines. This is the F1 engine.
Hold on.
Saturn V rocket was the one used to take men to the moon for the first time.
14, 13, 12, 11, 10, 9. We have ignition sequence start. The engines are on. 4, 3, 2, 1, 0. The sideways shaking was unbelievable. The vibration was so intense you couldn't see the instrument panel. We have cleared the tower. I thought we'd had it during launch. I was hoping that Frank Borman didn't have his hand on the abort controller. He said he took his hand off and he'd rather die than make a false abort.
1 minute after liftoff, the Saturn V is already supersonic.
Well, the Saturn V is still the most powerful machine that man has ever devised. 20 tons of fuel a second, 7.5 million pounds of thrust. I think we were all surprised at how strong that thing was. It had had 2 or 3 iffy missions before ours, but it was a piece of cake. It just worked beautifully. Unbelievable.
5 engines in the first stage blast the Saturn V to 7 times the speed of sound.
The second stage cut in. Big bang.
At 40 miles high, it's still
When
accelerating.
you staged, you were throwing forward in the belts and then backward in the belts.
And I thought I was being catapulted through the instrument panel.
All sources show that the stage is burning perfectly.
The third stage fires twice. First, the boost into orbit. The second burn takes the crew of Apollo 8 where no men have ever been.
Thank you for your interest in flight and rocketry. A special thanks to Ms. Dahlberg for inviting us in today.